Uh, it's extra stuff to handle, but all right. So parametric equations. All right, Luke, you said you'd done them
Yeah, they're a pain.
in
Because you
science.
have to do them like on an X and a Y scale.
Yes. They are equations that describe motion, which is why those of you who've had physics might have done this. But what they do, you got an object moving, they break it down into two parts. They describe the horizontal and the vertical motion. So they describe the horizontal motion and the vertical motion of an object in terms of time. That's mission critical. You're doing it in terms of time. That was supposed to be, that's not well spelled. We'll try again. Okay. So you're going to have an equation for horizontally, where is it at any time t, and vertically, where is the object at any time t. So you'll be able to say after 2 seconds, how far over was this object, how far up was this object. Timothy, you are being a distraction, and you're certainly not paying lickety-spit bit of attention to me.
I will do. First time, motion and vertical stuff.
Stuff. Okay. In our case, we only have time to do projectile motion. You can finally shoot something other than straight up. We can finally shoot it off at an angle here. So we will be helping the golfers with their golf game. Football,
Baseball. Baseball.
Help Todd learn how to launch correctly.
Okay.
You don't have to correct.
Okay, so if you started a coordinate system and technically when you hit a golf ball, when you shoot a rocket, whatever, at the moment it leaves, it is truly headed in a straight line. But does it stay in a straight line?
No.
Why?
Gravity.
Yeah, gravity takes over, and what shape does it become?
Parabola.
It becomes a parabola. So it starts out straight, but yes, it eventually turns and it becomes a parabola and comes back down. And so, but it is, we're going to think of it as a vector. It starts out as a vector. Your vector is going to have, they're going to tell you you hit it at a certain angle, or the rocket launched at a certain angle. I'm going to use 80 degrees as an example here. And they're going to tell you how fast it was moving when it launched. In this case, we're going with, say, 160 feet per second.
What about tanks? Can we use this for tanks?
This could be firing artillery out of tanks. Yes, actually, no. This is very much done by if you get in the military and you're doing artillery, you're going to learn these equations, these things specifically because they help you do your job.
Is that feet per second?
That's feet per second. Yes. Okay. What we have to do is we have to figure out. I want an equation that tells me how far over it is horizontally at time t and how high up it is at any moment in time. We break it down with parametrics. We break it into two parts. Okay. What formula do you know when we shoot things straight up in the air?
Develop plus abso, something like that.
Yeah. It was half. Okay, Vought is second. So is third. We're missing the beginning. It's
Something squared.
yes, it's half at squared. H is height. Okay. So H is height. What was A?
Acceleration.
Acceleration of what?
Gravity.
That is the acceleration of gravity. And so, depending on what unit you're working in, A is either going to be, it's going to be negative 9.8 if you're working in meters. It's close, negative 32 if you're in feet. So you're going to have to pay attention to, is my problem in meters or feet? You have to know those two numbers, yes.
What's that thing above A?
Thing above A.
No, the A equals negative 50. What's that? No, less than equal sign. What is it?
A? That's, sorry. A. Okay, I'm getting there. Okay, V is what? And why did you, Adam just said its initial velocity. Why did he know its initial velocity? Yeah, subscript of 0, that means at time 0. So that the moment you fire it, how fast is it moving? Initial velocity. T is, of course, time the whole time. And so S is, yeah. S in mathematics, S is position. But yeah, it's how high it was off the ground at the moment you fired it. Initial position. Okay, now, that formula is when we shot things straight up, straight down. We now want to shoot things at an angle. So we're going to have to alter our formulas just slightly. That was also the height. Is that your horizontal motion or your vertical motion? That would be your vertical motion. Okay, so when we do parametric equations, you're going to have an equation we call x sub t. So it's your x motion in terms of time, and then you're going to have your y motion in terms of time. You're actually going to have two equations to represent each object that you're firing. Okay, you all actually know the x formula already. Because when we're going horizontally, is gravity having any play in it? No. So, okay, I have an angle, I have a velocity. How did you just find x and y with your vectors? X equals velocity times sine of angle. Yes. You did the vector magnitude times cosine. And we know when we were doing our vectors, it was y was the magnitude of the vector times sine. Okay. So all we're doing here, though, when I go to do, I need it in terms of time. So your magnitude in this case would be like 160 feet per second. So how do you figure out how much distance you traveled if you went for 4 seconds? 160 feet divided by 4. Would you divide by 4? Because it's 160 feet over 1 second. It's 160 feet per second, and you're going for 4 seconds. You times it by 4. So all it is 160 feet. That's your magnitude times the amount of time you're traveling. And then we tack cosine on it, because that gives us our horizontal component of our vector. Okay. The vertical is slightly trickier, because the vertical's now got gravity. So we're going to alter our half-at squared formula here, and it's going to all stay the same except for the middle piece. This middle piece assumed we were going straight up and straight down. Now we want to shoot at an angle, so our vertical is going to be controlled by what our y vector is doing here. So instead of just having velocity times time, it's going to be your velocity times time times sine. You have to add that angle in there in order to shoot it off at an angle, plus so. Those two equations you are going to do on every single problem. You're going to live or die, those two, every single problem. I actually think parametrics are easier with this because you know you're doing those two formulas every time. You'll have to write those come test time. I'm not going to give you those formulas.
Wait, can we get one formula?
The one formula. You're going to have to write those two, and you're going to have to write law, sines, and cosines.
Yeah, do we have to know like the one where the A's and B's are mixed on law cosines?
Law cosines, you have to write me one version of it. I don't care which version.
Okay.
If you know one version, you can do any version. Okay, so those two formulas, they are our friends. Now let's actually work a problem. Oh, I should have preloaded this. All right.
We'll do it.
Okay, if I say he estimates the distance to the pin, the golfer's left, what's the pin?
In the hole.
The pin is the flag, meaning the distance to the hole.
Middle.
The flag coming, yeah, middle of the hole.
Oh, I put it in the hole.
The flagpole is called the pin. Okay, maybe I should double check. We all know who Tiger Woods is, right?
Yeah.
What sport are we playing here?
Golf.
Okay, we are playing golf. Just checking. Okay, I'll write that out. He estimates it's 220 yards from where his ball is. It's 220 yards to the hole. Okay. Of course, having done all the analysis of his swing, he knows that his swing will produce an initial velocity of 160 feet per second. You don't think he can have high-tech equipment and pay people to analyze all that? So he's going to produce an initial velocity of 160 feet per second at an angle of 28 degrees. Yes, we're going to have to, 3 feet in the yard. Sorry, Simone. The golf's done in yards. I'm sorry. It's a stupid system. We know it. But it's so, back when I was a kid, the federal government passed a law that we were going to change the metric system in 10 years.
Yeah, right.
Well, then they but what my husband told me it would cost him in dollars to replace tools. A lot of things are now metrics, and now you have to own both set of tools. Pricey.
I think eventually.
I hope.
It'll just sort of, but it won't be like that, where
It won't
we're
be
gonna
everything
change
full
every year.
turkey. It's gonna be gradual.
That's what I was saying.
Okay. All right. So here we go. We got Tiger Woods. Estimates it's 220 yards to the hole. He's gonna hit it at 160 feet per second at an angle of 28 degrees. Is he gonna land in the hole? There's the question. Okay. When you read one of these problems, you don't do anything except write out the 2 equations I just gave you.
If he lands in the hole, that ball's gonna just pop right.
You're right. It actually would here, but we aren't going to estimate how landing it in front of the hole and bouncing it.
It's possible, but usually they're playing on force that will just land right off the bat.
All right, there's your 2 formulas. So you're going to have to fill them in. What's our velocity? So we're going to have 160 times t is your variable. Cosine of what angle? 28. Okay, and then you're going to get your y equation, which is 1/2. Okay, which acceleration of velocity are we using?
52.
It's in feet, so we're going to have to do this in feet. So we're going to have to do 32. So I'm going to have, we agree it's negative 32. So what's 1/2 of negative 32? So it's going to be negative 16 t squared. Okay, the middle piece here, the VT sign, exact same thing you wrote up here, except you change it to sine. It's going to be 160t sine of 28 degrees. And then, what is the initial position? 0, because he's hitting it off the ground. So he's out on the fairway. He's not teeing off. He's trying to land on the green here, unless it's a super short hole. He's not teeing off.
You get a hole in one on par.
We could have him tee off, but sorry, we aren't. Right. So.
Have him start 1 inch off the ground.
Okay. He's going to hit the ball. We hope. That's the case. Now, to solve the question is, you actually usually have to solve 2 problems to get to the answer. You have to ask yourself, what do we know in this situation? We know the distance is 220 yards, which is how many feet? So yes, times by 3, it'll be 660 feet to the hole. Okay. Since you know that, is 660 your x, your horizontal distance, or the height you want to be at when you get there? That's the x. So therefore, can't you say that set x equal to 660, and then you're going to, can you solve for time? Because the only variable you've got left is time. How am I going to solve for t? Well, what math do I need to do here to get t by itself? Yeah. Divide by 160 cosine of 28. Get both of those to cancel. Okay. And you're going to have to punch that in your calculator and get a value. I actually have the answer is 4.7, rounded off.
Hey, Mrs. Meyer, speaking of golf, have you ever seen the movie Caddyshack?
I have. If you like stupidity, okay. Okay, 4.7 is 4.7 what? What did you just find? That's time. So it's going to take it 4.7 seconds to travel 220 yards or 660 feet. Okay, now how are you going to figure out though if it landed in the hole?
You gotta fill in the other formula with
Yeah. Because if I take that 4.7 seconds and I fill it into the other formula, what's it going to tell me?
It's gonna tell you your YT.
Well, it's going to tell me my Y. Y is my vertical. It's going to tell me how high the ball is when it gets to that point. Okay, if it lands in the hole, we want Y to be what? 0. So we just simply then need to take that equation, our YT equation, and we're subbing in our 4.7 seconds that we just got for T, and you're going to solve it. So it's going to be times sine of 28. We don't have to do the plus 0. And so it will tell us how high it is at that particular moment in time. And so now here's where we're going to have a golf debate. It comes out negative 0.39. What's that mean?
You just fell short.
Well, we want
Or
to
T,
zero within the
no,
hole.
he would have landed below the hole.
Yeah. Because if it's negative, that means it's down below ground level when it gets to that point. So yeah, probably hit just short of the hole. Then we have the big debate, would it have rolled in or not?
Depending on the terrain.
Yeah, it depends on.
If that
Thank
thing
you.
was sloping downhill, you probably would have gotten.